Hey, what's up guys, my name is Cherno. Welcome back to another code review. For those of you not familiar with this series, this is where I basically take a look at your code and try and give suggestions and or thoughts depending on what the project is. If you would like the opportunity to appear on the next episode of the code review series, then read the description. There'll be some information as well as an email address where you can send your code to. So today I thought we would do something a little bit different for this series. In the past, we've been looking at like graphical projects, mostly stuff that we can look at on the screen, whether that be like a 2D game engine or a game or some kind of like particle demo. That's what we looked at last time. I'll have that video linked up there. But I know a lot of you watching my videos are just students, and maybe it's even your first or second year of university. You're going through and learning about all these different data structures. So what I have today is an actual real-world university assignment where the task was to write a hash map. This particular person who sent in this code wishes to remain anonymous, probably because this actually was a university assignment and maybe there are certain rules against sharing them, but for the purposes of this, we'll call him Tim. That may or may not be his real name. So Tim has sent in a single file implementation of this. There's about 200 lines of code here, as well as the actual university assignment sheet, which is really cool because I'll actually see what the requirements are. I think that it's worth noting that with these university assignments, I mean, I remember the ones that I kind of got, some of them had weird requirements, and the marking criteria was also not really what I expected. If you contrast that with real world code, like if I was actually writing a hash map for my own purposes, it would probably be vastly different than code that's specifically written for a university assignment. So it's going to be really interesting to actually take a look at a university assignment. But before we jump in, I just want to mention that this video is sponsored by Skillshare. For those of you who don't know, Skillshare is an amazing online learning community where millions of creative and curious people from all around the world come together to learn new skills. Basically, it's a platform with concise, informative, high-quality classes that will teach you almost anything you want to learn. Whether you are interested in photography, videography, more business side topics like business management, productivity, marketing, or one of my personal favorites, illustration, Skillshare has you covered. I've mentioned this before, but I think that their illustration classes, some of the illustration classes that they have there are absolutely phenomenal, and it's just so relaxing to chill out after a long work day and just draw something. That's one of my favorite things to do right now. Coming in at just under $10 a month for an annual subscription, Skillshare is also fantastic value. I honestly don't think there is any other platform out there that has so much information condensed into such a consumable format. A lot of their classes have videos that are like 5 to 10 minutes long, which is perfect if you only have a spare moment. But for a limited time, Skillshare is giving the first 1,000 people who click the link in the description below a free trial of Skillshare Premium so that you can access their whole library for free and see what they have. I highly recommend you do that. You will not be disappointed. Huge thank you to Skillshare as always for sponsoring this video. Let's take a look at some of this code. I think it's amazing that you have to submit this via SVN. So before we jump into the code that is in front of us and take a look, I've been reading this assignment sheet. I don't really want to show it because it gives like the name of the university. There's a bunch of stuff here, you know, we'll just ignore this. You guys will just have to take my word for it. But this is like, what an assignment this is. I mean, I don't know who wrote this. It's just very strange. Like, it's odd to me because I feel like the assignment could have been, you know, just write a hash map that works maybe like for strings, hashes strings, you know, generates like a little index as to where to store your data, and then like let us be able to retrieve this and maybe basically avoid some, you know, collisions in most cases with the test data. Like that would be a reasonable assignment. This is very interesting, and I think it's almost more fun that you guys don't know what I'm seeing, because as we look through this code, I think it's going to be quite amazing. Anyway, so first of all, there's a disclaimer here, which I think is great. Assignment requirements set by the hash table size, set the hash table size at 26. I have verified that is in fact the case, which is also the maximum amount of entries. I know this is bad for two reasons. 26 is not prime. Preferred size of the table is 26 times 1.3 to minimize the chance of collisions. Sure. However, this is assignment requirements. Yes, some of the assignment requirements are a bit weird. Let's, so this is all the code that we have here. Let's maybe start with the main function, because that's a good place to start reading code from, I think. So the first thing we do is create a string called str. Now this is already a, you know, I'm going to start the critique here. Don't do this, like name the variables. So what is str? I mean, you know, I can maybe deduce that str is going into, you know, get line cin. So this is us taking input from the console. So like maybe something like, you know, at least input, or like, you know, input string or like, you know, whatever, something a little bit more descriptive than str, because that's a little bit annoying. Like this is called user input, but this, you know, not the biggest fan of this. Okay, good. So we get the line from cin, sure. Then we send it into the input formatter function, which is all the way up here. This takes the string, this copies the string, and then I guess has an output of user input. Now, one thing I personally like doing, you don't really need to do this if you don't want to, but I like, well, first of all, I like writing the, you know, the asterisk or the reference, the ampersand reference operator on this side. I know some people prefer it on this, and there are reasons for both, but that's besides the point. My point is that user input is clearly meant to be an output, right? This is where this data is being pushed to. So what I would do is just name it something like out user input. That just makes a little bit more sense as to like what's going on with user input, especially if the variable is called input, because that almost implies that maybe this returns something, but it doesn't. That's also an option, you know, return, you know, in this case, we're creating a, are we using this function a lot actually? No, we never use it again. So this would be a good example of maybe having that vector be a return value, because then these two lines and all of this kind of code would just be simplified to, hey, you know, let's take in this string and then let's format it into this vector of strings. So that might be a little bit easier to understand, which is always good. By the way, with these like code reviews, I mean, even right now, I'm just looking at this code and I'm going to give some advice as to how maybe to write the code better. Like the thing is, the requirements for this assignment are set in stone and they are pretty not flexible. And I think my favorite part of the requirements was also how it says that marking will be done automatically. The total mark is 10, 1 for compiling. So I guess if it compiles, you get 1 mark, and 9 for 9 test cases. I don't know if it doesn't outline the actual test case, but it gives you some sample inputs and kind of expected outputs. But in general, the requirements are very specific. I think that if anything, this is maybe teaching how to follow requirements, because again, they're just very like real world use case kind of requirements. Anyway, so what do we do here? So we go through the size of the string, which again is the input. Now, the first thing I would do here, by the way, is definitely not take this string in as a copy like this. Like that definitely doesn't need to be done. Now, this is an existing string. You basically have two options. You can take it in as a const reference. That's probably what I would do, because I tend to do that a lot. The other thing you could do is just use a string view. That's just basically a view into that string that just, it doesn't copy it. It's almost like passing a pointer to the string data with like an end point as well. So that will just make it a little bit better, because you won't have to actually copy that string, which of course is a little bit of a waste of time. Not that this is a performance issue. It's absolutely not. We run this once at the start of our program. No one's even going to notice that. But for future use, I think that's helpful advice. Going through every character in the string is our next case. And if the string character does not equal 32, okay, please don't do this. Just write code like this, right? So 32 is the ASCII value. 32 in decimal is the ASCII value for a space. This code is already a lot more readable. I mean, who on earth understands that 32 is a thing? So yeah, write code like that. It's going to be better. One thing I noticed with a lot of this code that actually people send me is just the formatting is just bad. Like, for example, you know, we have a new line for this and for this, for these braces, but then this one just is on the same line for some reason. This one's on a new line, but that's on the same line. It's a little bit inconsistent. So if you're not using like Visual Studio or like an IDE with an auto formatter, just because I know Visual Studio will try and clean this stuff up for you, whereas other tools will actually have you like run, I guess, a command or something to make it happen. Just, you know, maybe just clean it up and make sure it looks good. Again, this does not affect the, apparently this does not affect the result of the assignment, because it's marked automatically by a computer, I would imagine, and if it compiles and succeeds with the 9 test cases, that's 100%. So why bother, I guess, but I would still do that. And removing like all these comments, which again, does not affect the assignment grade. So it's, I'm not digging this assignment. So yeah, I would basically format things like this. Okay, so if it's not a space, we basically have a temp string that we append to. Okay, this is bad for a number of reasons. What I would do though is rewrite this whole algorithm with basically, instead of actually iterating through every character as if this is like the Stone Age, just use some more modern kind of STL functions, and particularly string has something called like find, which will actually try and look for something like a space within the string. Don't remember the exact like signature of this function, but what you can do is actually recursively do that until it's like until you've searched the whole string, and then just take each, because that will return the position of the space. You can use that to basically substring, you know, all of the other string functions and create new strings out of them, which seems to be the intended output of this function, substring. So I would basically do that. That would just be a little bit of a better way to parse this, you know, unless you want to like full on create like a tokenizer, which I probably wouldn't. There's also a C API that you can use. I remember using this back in the day, string, I guess. I think that also returns a pointer to a const char array that is at what you're looking for, something like that. But basically, using the library a little bit more than writing this by hand would just be easier. And again, the point of this assignment is clearly not to do this. All you're trying to do here is sort out your input, basically split string by space. And C++ doesn't have like a little, you know, string.split thing where you can just split it by space and get an array back like a lot of other languages do. So using something like find and substring is probably your best bet. Otherwise, that's that function sorted. By the way, let me know what you guys think about the level of detail I'm going into with all these. Like, should I just, you know, this isn't very big. That's why I'm doing this. If it was like 100 files, obviously I couldn't do that. But anyway, if this is, yeah, just let me know. All right, so number of inputs, user input.size. Okay, so this is an example of variables that I think are useless. Num input, if this was called something like completely different, then I would probably see some worth as to creating like a variable out of it. So like number of like apples or something, right? From user input.size. That adds so much meaning to what that actually is. What this is, num input, you don't need that variable because the variable is here, right? Instead of using num input, you could just use this. Another reason to have num input is if you changed it, which you don't, right? So if you were like going to decrement it or something like that, then of course you'd have to bring it onto a variable. But I would just skip that. Have less variables unless, you know, the way that you get like the data you need is like a huge string. Then maybe you would want to simplify that into like an alias using a reference or bring it out into a variable like this. But otherwise, I would just rewrite that code like that, basically. Okay, and then we have our hash table. Okay, cool. So hash map, hash table, by the way, same thing, obviously. Unordered map is also what C++ calls it. So let's look at the hash table class, which is like 3 lines of code. Okay, cool. So hash table, it's a class. That's good. Public status object. Okay, and then the constructor sets the status to never used. Now, I probably would have thought that this was just a debugging thing, but actually it's like, it's in the assignment. Like, you have to set, a table slot has 3 different statuses: never used, tombstone, and occupied. The table starts with 26 never used slots. So this is all legit, just so you guys know. I just want to make that clear. Anyway, so we create 26 of these. All right. So first of all, we don't need to set this up like this at all. The first thing I want to say, actually, if we go back to this hash table class here, right, is that you don't need a constructor. You can just set the status to never used up here, right? And then just not have a constructor. The reason being that when it gets initialized, like this isn't like prior to C++ 11 when you couldn't have assignments like this in like header file, well, in header files, in like class declarations like this. So we can definitely do that, and that will probably be better, and it would just reduce the need for this code. This is also useless because it's the same as just calling the default constructor. So I would basically rewrite this class to look something like this. And again, because it's a public bunch of members, I would also remove this and just make it a struct. No difference between a struct or a class, apart from the fact that structs are public by default if you don't specify something, whereas classes are essentially private by default. They're members, I mean. So that's how I would rewrite this class. However, at the very least, what you could have done is just basically ran status with never used like this in kind of the constructor, I guess, initializer list. The reason being that that prevents the string from being created twice. Once up here, again, it's an empty string. This point is not about like performance. It's just more about like code style and what actually is happening so that you're more aware. You know, in this case, it creates a string up here, and then also it would have created it down here again, reassigned it to something else, and constructed a string out of this kind of const char pointer, essentially using an implicit constructor. Again, so you've kind of made two strings. Whereas if you write one of these bad boys, it basically replaces whatever you wrote here. So this is now meaningless. It will instead use this. So that's kind of important. But again, you know, in this case, I would not do anything like this. By the way, I don't know what version of C++ this needs to compile with. I think it actually did mention, okay, yeah, C++ 11 with optimization level 2 using G++. That is what's going on here. Okay, cool. Interesting. So yeah, C++ 11 definitely supports everything that I'm doing. So this is how I would rewrite this, basically, and just get rid of that because you don't need it. Okay, we create 26 of these. Now this is the other thing. You could create like this. You could just use an array as well. So we could have an array of like hash table objects like this, 26 of them. This is what I would do again. The reason being that we now have size. The biggest reason honestly for this is that apart from having some nice functions to help us out with certain things, we have a size, right? A size that isn't really stored as a variable, but that we can retrieve using an API like this. That's a lot better than having to use the value 26, you know, here, for example. You would just write something like array of object.size, and that would be that. Speaking of which, you actually don't need this for loop whatsoever. There are a few ways to actually fill an array. You could use something like std fill, but I would instead use this. So if you just do that or assign it to essentially an empty set of parentheses of curly brackets rather, like this, then it's actually going to initialize all of the objects with, you know, whatever value you set there, which is nothing, meaning that the default constructor will be called for all 26 of these objects, meaning that you don't need this for loop like whatsoever. So you could just completely remove that. I'm gonna, by the way, keep the original code. If you guys wanna see like a video of me completely rewriting this entire assignment the way I would write it, let me know in the comments below. But obviously I'm trying to do a code review here and not rewrite everything. So I'm gonna probably stop doing this in the future, for this video, I mean. But basically, yeah, do something like this and it means that you don't need any of this. In this case, this is used for just initializing all the elements. But if you had something a little bit more simple, like maybe, you know, 5 integers, you could also use this to essentially give a value for each of the integers. So initialize the lists are great. Okay, anyway, moving on. So we've chosen to go with this, which is fine. And then that means that, yeah, essentially we do need to initialize it using an algorithm like this, or a for loop like this. Okay, and then we go through the user input.size. So this is now the kind of separated by spaces, tokenized kind of commands, I guess, that we've given in the user input. So what are the commands that we can handle? So we have this function called command get. Now, again, you know, this is a very interesting code style, right? Like literally every single style has been used here in terms of function names. Like, I mean, literally, like we have this, I don't even know what this one's called, this kind of snake case, but then with the capital second word letter like get. We have this kind of, I think Pascal case is what it's called. It's very like Microsoft style. We've got this one, which again could be, I guess, snake case. Then we've got this one, which is camel case. We've got them all. we've got them all. Input formatter is another example of Pascal case. So I don't know why. Just stick to one and just use it. Very important because. See, the thing is, I can't even give this advice because you still get 100% if you get this. Anyway, whatever. Okay, it doesn't matter. We'll move on. We'll move on from that. So command get, user input I. Okay, so we give it a character, a single character. No, sorry. User input's a vector. So we give it a string, essentially. So this is probably also by, oh, no, this is by reference. Okay, that's better. I guess it's going to actually write out to that string. Yeah, it resizes the string. So what does this do? So we get the first character. We then resize the string. Oh, so you are using substring, so you're aware of that, which is good. We get the first character. We basically use this temp string thing here to just resize this to be or not resize it, but to basically select, the entire string minus the first character, basically. So we drop the first character from the string and assign it to temp string. Then we resize the string, and then we reassign it, which defeats the purpose of resizing it here for no reason. Okay, this is all very messy. This is what you need. This is what you're trying to do, I think. I think you're just trying to do this without any of this. You're just trying to take the string and reassign it to basically a substring of that original string that doesn't include the first character. So we can just leave it at that and not get too crazy. And then we return the very first character. So we've saved out the first character into a variable because we're changing it. We're changing what the string is. We're dropping that first character, and that's what we return. Seems weird, right? Well, actually, it's because the assignment says that the way that we give commands to this program is we basically have to have the first character specified as either A or D, in which case A means that we add to the hash map, and then D means we delete. So in other words, an example command might be like, I want to add Cherno to the hash map, and then I want to delete Cherno from the hash map. That's literally what you do. You just do this. So that's why we're looking at that first character. And then kind of separating it, because obviously this is the actual value we want to add, but then this is what says what to do. So again, a very creative assignment. So what do we do? Okay, so basically what this switch case is now operating on that very first character, whereas the user input has now been modified to contain not the first character. So we've kind of trimmed that off. We just have the key, I guess, that we're actually trying to add to the map. Which begs the question, is it really a map if all we're doing is adding keys without values? This is more of like a hash set, to be honest, at this point in time. So, but I guess maybe we are storing some kind of associated. Anyway, let's not jump the gun. Let's see what's happening. So the first thing we do if we want to add something is we search. So remember, array of objects is that hash table array, which hash table really is just two strings. Object, which I guess stores the actual value, and then status, which is a string that is initialized with never used. So then we go through this, we search. Okay, so let's go through this first of all. So we take the actual string, so like Cherno. We'll leave this up here so that it's clear what the command was. A Cherno. So now we know that this user input contains just Cherno. We put it into the hash function. So the hash function sees Cherno. What's our hash function? I think this is a bad function because words ending in the same letter will end up being placed in the same slot in the hash table. Why, yes, that does sound bad. But I also don't know how to write a better function using only the one character, so I will keep going. Only the one character, yes, because I think I remember something in the assignment talking about how you're only allowed to use a single character to generate a unique hash. What is happening? Anyway, whatever. So what do we do here? We do char get string. What does that function do? It returns the last character in the string. And of course it has time to copy the string. Okay, so first things first. Don't do this. You can just, do something like string size -1 here, right? Doesn't need to be a function. And instead of calling this ch, which is almost, the beginning of a good word, you could instead actually call this something like last character. That immediately makes this algorithm, or this hash function, way more readable, right? So then we do int constant, and then we do, oh look, you know how to use these things in like mathematical operations. So definitely then you should have done the space. Where was it? This is also not very well organized, but we won't get into that too much. In here, right? You should have done that. Okay, back to the hash function. So int constant equals, so the last character, then we subtract the ASCII value of 0, which I would say I know what that is, but I'd be lying. So let me just get back my ASCII table. So 0 is in fact 48. So that's kind of like the start of, I guess, the usable characters, because anything below that is a symbol like divided by or comma or plus. And then anything above that, we basically, we have our numbers, then we have like colon, semicolon, stuff like that. And then we have capital letters and then lowercase letters. So that's kind of like, I guess this is almost like our 0. And then we subtract. So basically any character really is guaranteed to be above 0 most likely, unless we're giving it like a character that we shouldn't be, maybe, like as far as this assignment goes. We add 3 to it, which is a bit weird. So we get kind of the value from that start. We get 3, and then we mod it by 26. And that is what our index, I guess, is, or like at least our hash function. Very interesting. And again, it's just taking that last character. So this obviously only really functions on the last character. Now, the fact that this is already mod 26 and 26 happens to be the size means that this probably actually, this isn't just the hash function that generates a hash for us. It actually specifies what bucket that we should be storing our value in or retrieving our value from. So this actually gives us back that index. So hash maps obviously store all of their values in various buckets, and the hash function, the point of the hash function is to generate a value that can then be used to actually get an index, and then you can see where your data should be or is. So that's what this is doing. So it's kind of doing 2-in-1 here. Okay, cool. So that's our hash function. So now we basically get back an index as to where to store our data. That's the point. That's our data, and that's my array. So search is doing that. So I guess the thing is we're already specifying something. So it's not like we're searching by string. So what exactly does this search function do? What exactly does this search function does? Okay, so we're taking an array. Sure. I'd probably write this a little bit differently. I think this is kind of old school. Not that it's a huge, difference in this case. And we have a place here. So we actually, so we basically check to see if, this is almost like a little collision check. We check to see if the array contains an object that has the same name as the one we're trying to insert, I guess. And if so, we return -1. Otherwise, if the status is never used, so obviously it doesn't equal now, so it's either never used or it's occupied. Never used, of course, being this status here. Very important that you spell that right and don't use capital or lowercase letters accidentally or something like that, or write it as one word, because otherwise the whole algorithm breaks. So yeah, extremely important to when you're dealing with strings as statuses for some reason. But again, assignment requirements. Value cannot be used in the hash table. This object doesn't exist. So I think it means can be used in the hash table, maybe, because this obviously means that it's free. Otherwise, if it's occupied, we try and basically resolve that collision, I guess, by just like doing something like this. Again, what you could do is not do this, but use that beautiful modulus operator you were using earlier to just basically make it so that you do something like place +1 mod 26, maybe like that. And then that's kind of just a little bit of a better way to write that little bit of code, so you don't need the if statement. And then we basically recursively try and see, like, okay, well, let's increment the index and then see if that's free. So a little bit of collision kind of avoidance, I guess, but this is also slightly dangerous, because if they are all occupied, this will just crash with the Stack Overflow exception, because you never stop searching, and if you've exhausted all 26 slots, that's the end of the day. That's the end. So let's not do it that way. But anyway, if this doesn't return -1, then obviously we're good. We have an index for it. So now we do search for free. So there's a lot of stuff going on here that seemingly shouldn't be happening. Like, what we've searched already, we know that it's free. Why are we searching again? Not sure, but anyway, this basically does the same thing. This actually looks almost the same as the other function, but I mean, I don't know. Again, recursively tries to like increment the index, search for a new kind of place if there's a collision. Otherwise, if it's never used or it's a tombstone, meaning I guess the object has been deleted, it used to be there but has been deleted, then we get that index back. So yeah, not sure. I mean, ideally, again, into an empty hash table, in this program, you would just immediately get your place. So I don't know why this is happening. And in fact, doesn't search return? It does return an integer. So I mean, this has nothing to do with the whole tombstone situation. So what you can do is basically do either never used or tombstone, right? And in that case, if it's never used or tombstone, then obviously you can use that slot and then basically just do something like in place equals search up here. And then, well, that's it. You don't need that other function. You can just go ahead and add it. So I would do something like that. Okay, anyway, so now we have the index yet again. I wouldn't call it place either, I'd call it index. Sounds a bit more professional, I guess, and a bit more descriptive, but I guess they mean the same thing, right? At the end of the day, don't they? And then add. So what does add do? It changes the status and just copies the object, copies the string into there. Again, no reason to do something like this, you know, just do that. Or at the very least, if you're going to move this in, then maybe you could, you know, move it in. You know, this is beyond the assignment and I don't really care. So let's move on. Move on. So we break, which is good. And then that's how we add objects, basically. Pretty straightforward. How do we delete objects? So we have, again, the search function, which, now this is interesting, right? So, okay, all right, okay, yeah. So we need to make sure that we find whether or not that object exists. And then we find the place of it. Actually, hang on. Am I misunderstanding something? So what does this do? So search looks for something, and then if it is occupied, oh, right. Well, -1 just means it can't find, no, -1 means it's found it. So in that case, it doesn't give us a place. Yeah, okay. No, so it's fine. My thing still works because if it's -1, it means like I guess it already exists, then it does nothing because this wouldn't be true. So actually, like, to be fair, when I wrote my thing, you know, I should have surrounded it with more parentheses so that we actually check that variable then with -1. Otherwise, that wouldn't really work. But anyway, so yeah, so we do the same thing here. We basically, this is just us checking to make sure that it exists in the hash table. If it doesn't, we can't delete it, right? It's not there. So if it does exist, we again search for it, because search returns -1 if it exists, which means that we don't get the index of where it exists. It'd be nice to have that as an output variable if you had done something like that. You know, had like a little out index or whatever, if it does in fact find it. If the function itself doesn't return the index, which also wouldn't have been a bad idea. We're trying to search for something and we get an index. But anyway, so now we do search for kill. A nicely named function. And this basically, I guess, if it finds the string and the status is not tombstone, then we found it and it's not dead, so we can kill it, I guess. Otherwise, if it's occupied, I don't understand why this happens. Like, surely this is just us trying to find the object that we now need to delete. So, and then we're trying to find the index of it. So why would we recursively try and, oh, no, hang on. I see. Okay, yeah, this has to exist because if we previously had a collision, then we shifted it. So it's possible that even though the hash function says that you're at index 5, you may have actually been at like index 7 because when you were inserted into the hash map, it incremented your index twice because there were collisions. So that's us doing the same thing here. Yeah, what you need to do is cut this 3 different search functions to just a single search function that just tells you the status potentially, whether or not the object, if the object exists and you're trying to find that, the index of the found object, and then maybe like, you know, an empty place or something like that. Again, maybe 2 functions, one for like add and one for actual search, because search, again, search to me, you know, is kind of like a find function, in which case you'd expect it to return an existing object, right? Or nothing, maybe -1 if it couldn't find it at all. But this actually returns -1 if it does find it. So it's a little bit weird. Anyway, and then finally we delete it. So how do we do that? We pass in that array, we pass in the string by value again, and then we have the index. So we basically do another check to see if they're equal. Okay. And then we set the status to tombstone. So we leave the data there, but we've just set it to tombstone, meaning it can be reused. Cool. And that's kind of it. So the output is the good thing. So basically we just go through all 26 values here and we just see if the status is occupied. So if it's been deleted, it will be tombstone. If it's never used, it'll be never used. But if it's occupied, then that's good. That means we basically print it along with a space, which the assignment says is the expected output, and then we return 0. So that is the hash table assignment. Yeah, wow. That's this is I have to say this is not at all what I expected. Okay, so I hope you guys enjoyed this video. If you did, please don't forget to hit the like button. As I mentioned earlier, you can submit your code to me for review by emailing chernoreview@gmail.com. There will be that email address in the description below, as well as some instructions. I hope that you guys have a great rest of your day, and don't forget that you can check out Skillshare for free by using the link in the description below. I'll see you guys next time. Goodbye.